Okay, we're going to look at the season relative forecast. What a season relative forecast is, it's really just a series of averages. First, we take the center moving average of 4 quarters. Then we calculate the average of the average using a 2-period center moving average. We calculate the season relative, and then we take the average of the season relatives. Of course, the more data we get, the more accurate our average seasonal rate relative becomes. And from that, we can compute the next year or 2 years out quarterly forecast. This is just kind of a graph of the data we'll be using. We're going to use a bicycle example, Blackwater bicycle. Of course, in the summer season, we're going to sell more bicycles than we are in the middle of winter. As you can see, the data is all over the place because there's a big seasonal curve here over the 4 quarters. If we just use simple linear regression, which I calculated here, we can tell our coefficient of correlation isn't very good. It's telling us only that 17.5% of the change year over year is due to sales. And of course, to forecast, we need something a lot more accurate than that. Okay, so the first thing we do is calculate a 4-month center moving average, because we're using 4 quarters here. So it's simply the same thing as a regular moving average. We take the 4 months, and 1, 2, 3, 4, we divide it by 4. That gives us the average of these 4 months. Notice, though, when you're taking an average of 4 months, our result is actually in between quarter 2 and 3 here. All right? And we continue that down. We take another 4-month moving average, which will give us a result in between 3 and 4. And if we add those up, we get 256 1/4. But again, I just shifted down, took the average of the next 4 months. We keep going the same way all the way down. Okay, so our second step is to take the center moving average of the center moving averages, or in other words, the average of the average. Once again, why we're doing this is because the CMA4, if you average 4 numbers together, we're coming in somewhere around 2.5. Whereas we average these two together, it gives us a number that's relative for quarter 3. So this is the CMA2 of quarter 3, quarter 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. So again, we take the CMA, the average of the averages. Here I plotted out the CMA2, or the 2-period center moving average, which is kind of the average of the averages. And you can see that we start getting more of a defined trend line here. Actually, as we calculated the linear equation for the CM2, we could see our coefficient of correlation now goes up to 96.5%. which is telling us that a lot of the change year over year is actually due to our increase in sales. Okay, step 3 is we calculate the season relative. And the way we do that is we take the actual, which is our actual sales were 520 million. We divide that by our CMA2, and that gives us a season relative. So it's the actual, and since we're dealing with quarter 3 now in our CMA2, it is, quarter 3 actual, which is 520, divided by the CMA2 for quarter 3. And we just continue that right down the line. So actual over CMA2. All right, so the final thing is we find our average season relative. So I filled in the quarters here next to all the numbers. All I did for quarter 1 is take my 1, 2, 3 quarter 1 season relatives, add them together and divide by 3. I did the same thing for my quarter 2s, added them together, divided by the amount of quarters. Likewise for quarter 3 and quarter 4. One thing to note, if we add up all these numbers, we get 4, or respectively about 400%. I'll show you why that's important in a second. But the big thing to know right now is these are our season relatives, and of course the more years of data, quarterly data we add, the more accurate our forecast will become. All right, so finally, all I did is I took my average season relative and expressed it as a percentage. You notice again, if we added up the 4 quarters of data, that they equal 4 or 400%. So I just divided the quarterly average season relative by the total, which is 4. So we can see that first quarter sales are just under 6% of our yearly total, versus the summer months, which are close to 50% of our sales. Add these up, you notice they all equal 100%. And finally, we're ready to forecast. We have 4 years of data. We want to forecast for our 5th year. So just for forecast data, I did a linear trend equation on the first 4 years total sales. This is my equation right here. So my year 5, I'm forecasting $2,600,000 worth of sales, or if I divide that by 4, roughly $650 million per quarter. All right, to get our forecast, it all depends upon which version of the average season relative you use. If you use the percentage method, we take our total yearly forecast, 2,600, and multiply it by the year quarterly percentage. Like 2,600, this was just under 6% for quarter 2. You can see we did about 33% in quarter 2. That should have been quarter 1. And quarter 3, we just do under 50. And finally, 12.5% in quarter 4. The other way of doing it is we take our average season relative and we multiply it by our per quarter quantity here. So again, for quarter 1, it was what, 0.234 times 650, 1.3 times 650, 1.9 times 650, and 0.5 times 650. You can see that they're basically the same numbers within a round-off error.